AP Calculus, Homework 1.2. Find the limit of each value. If a limit doesn't exist, state why it doesn't. So number one, we can use direct substitution for this and get 3 times negative 1/2 squared times 2 times negative 1/2 minus 1. Parentheses are getting a little crazy. Negative 1/2 squared is a fourth. 4 times 3 is 3/4. 2 times negative 1/2 is negative 1. Negative 1 minus 1 is a negative 2. Cross canceling here, 4 goes into, you can divide both 2 and 4 by 2. So that's going to be negative 1 and 2. It's going to give us negative 3 over 2. Number 2, we can use substitution for this one as well. We're going to have a negative 1 cubed plus 2 times negative 1 squared minus 3 times negative 1 plus 3. If you have a negative raised to an odd exponent, it's going to be negative. If you have a negative raised to an even exponent, it's going to be positive. So negative 1 squared is 1, 2 times 1 is 2. A minus 3 times a negative 1 is a plus 3. Bring down the other plus 3. This is going to give us 6, 7, 8 minus 1. It's going to give us 7. Number 3, direct substitution works yet again. We're going to have negative 2 minus 6 to the 2/3. That's negative 8 to the 2/3. Just to remind you what the negative 8 to the 2/3 means, it means the cubed root of negative 8, and then you square it. Cubed root of negative 8 is negative 2. If you square that, you're going to get 4. Number 4, direct substitution still works. We could put a 2 into the numerator. We could put a 2 into the denominator. 2 squared is 4. 5 times 2 is 10. 2 plus 2 is 4. It's going to give us 20 over 4, which is 5. Number 5, direct substitution works yet again. This really should be in parentheses. I apologize for it not being that way. It's going to give us pi over 6 squared times tangent of pi over 6. Pi over 6 squared is pi squared over 36. And what is tangent of pi over 6? Let me remind you in case you don't remember. Pi over 6 is in quadrant 1. Pi over 6 is the same as 30. That makes us say 30, 60, 90. I'm not going to use the unit circle for this. Instead, I'm going to use the same principles. I'm going to make the smallest side 1. Opposite 30 is the smallest side. The hypotenuse is twice that. And the side opposite of 60, the long leg, is the short leg times the square root of 3. So therefore, tangent of pi over 6 is y over x. That's a 1 over the square root of 3. This then is pi squared over 36 square roots of 3. You do not have to rationalize your denominator. If you want to, you can, and in some cases you'll need to. If in fact it's a multiple choice question, you have to fit the format that the answers are in. If it's a free response question, you do not have to. You could leave it simply like this. Number 6, if we try to use direct substitution for this, it will not work because we are going to be dividing by 0. So what could we do? We could multiply this top out. Let's see what happens. We've got to figure out how to get rid of this x on the bottom. X plus 4 squared, that's going to be x squared plus 8x plus 16. And we can cancel these 16s that are here because we've got a plus and a minus. We could factor an x out of the numerator. By doing that, we can cancel an x from the top and the bottom. That means there's a hole in the graph at x equals 0, which explains why we couldn't use direct substitution. Can't find the y value when there is no y value at the x value. To evaluate the limit, we then put 0 in for the x. Once you evaluate the limit, you stop using limit notation. So this is 8. This means that this graph has a hole at 0, 8. Number 7, direct substitution will not work for this one as well. If we try to do that, we're going to end up with 0 in the denominator, which is undefined. Let's see if we can factor this. The top is already prime. The bottom is the difference of two squares. X minus 1 cancels from the top and the bottom. When you cancel using division, you're left with a 1. Using substitution, put a 1 in for the x, we end up with a half. This graph has a hole at 1, 1/2. It's not relevant to the answer, but I'm just reminding you what that means. 8, this little fella also factors. The top is going to factor into an x minus 2 and an x minus 1. The denominator factors into an x minus 2 and an x plus 2. The x minus 2's cancel. So we're left with the limit as x approaches 2 of x minus 1 over x plus 2. You must continue to use limit notation until you evaluate the limit. We can now evaluate the limit, and we're going to get 1/4. Number 9. Direct substitution is going to give 0 on our denominator, so let's see if we can factor. And if we simply factor out the GCF of the top and the bottom, wonderful things are going to happen. The x squareds are going to cancel from the top and the bottom. So now we have the limit as x approaches 0 of 5x plus 8 over 3x squared minus 16. Using substitution, we're going to end up with 8 over negative 16, which is negative 1/2. Number 10, direct substitution will not work for this. Let's see, what can we do? If we try to use direct substitution, we're going to be dividing by 0. Let's multiply every term by x plus 2 and 2 on the top and the bottom. So we got the negative 1/2, we're going to multiply by that. This first fraction, we're going to multiply that. We're going to multiply the denominator by that. What's that going to give us? It's going to get the limit as x approaches 0. This first term, the x plus 2's cancel. You have 2 times 1, which is 2. The second term, the 2's cancel, so you have a minus an x plus 2, which is a minus x and a minus 2. Our denominator, let's not multiply this stuff out because we're not looking for things down there to cancel. A plus 2 and a minus 2 cancels. So now our numerator is a negative x. Just rewriting some terms. I got 2 times x plus 2. Cancel an x from the top and the bottom. Now we have the limit as x approaches 0 of negative 1 over 2 times the sum of x and 2. If we evaluate the limit now, it's going to be defined. So we just put a 0 in for all of our x's, so the 1x. It's going to give us negative 1 over 2 times 2. That is a negative 1/4. Number 11, I'm going to do something crazy with 11. This is super crazy. Now we could multiply all this out. X plus 2 times x plus 2 plus x times x plus 2. And if you did, the 8s would cancel and you could factor an x out. Let's try something a little crazier. Let's factor this. This is a difference of two cubes. This is a cube, it's cubed. This is a cube, this is the same as 2 cubed. This factors into a binomial and a trinomial. Now this binomial is going to be the square root of this, the cubed root of this, which is 2 plus x, minus the cubed root of this, which is 2. Now that binomial that I said this was is actually a trinomial, but we're looking at it as this is the first term, this is the second term. And then how's the rest of this trinomial go? Well, you take the 2 plus x squared you take 2 plus x times this 2, and this is going to be a plus. We'll talk about the signs here in a second. Run out of space here. Elongate this. And then we're subtracting a 2 squared here. Actually, it's going to be a plus a 2 squared, which is 4. So let's review what just happened because I didn't make that super clear. To factor the difference of two cubes, you take the cubed root of the first term and put that in the first part of the binomial, the cubed root of the second part and put that in the second position of the binomial. As far as your signs go, it is SOAP, same as this one was, opposite, and then always positive. The first position of this trinomial is the cubed root of this squared. The last position of the trinomial is the cubed root of this squared. And the middle term is the product of these two terms, of these two cubed roots, which is what this is. Now, how does that help us? Well, these twos cancel. That's how it helps us. Since those twos cancel, we have the limit as x approaches 0 of x. I'm just going to rewrite some of these terms. Instead of 2 plus x, I'm going to write x plus 2. That 2 plus x drives me absolutely batty. We can cancel an x from the top and the bottom. Once we do that, we can now use substitution to evaluate this. We no longer have a fraction. If I put a 0 in for my x's, I'm going to have 0 plus 2 squared plus 2 times 0 plus 2 plus 4. It's going to be 2 squared plus 2 times 2 plus 4. Which is 4 plus 4 plus 4, which is 12. If you don't like the fact that I just factored this here at the beginning, then don't. Multiply this out. 8s will cancel, and then you can factor an x out, and you're going to get the same result. It's going to look a lot different. All right, to number 12. This is a special problem that you don't realize yet, but someday we'll talk about it. We cannot evaluate this currently because we're dividing by this h, which is approaching 0. So what we're going to have to do is we're going to have to multiply all this stuff out to try to get an h to cancel. Sum of x and h squared is x squared plus 2hx plus h squared. If we distribute the 2, we're going to get plus 2x plus 2h. And then we have a minus 3. And then we're going to distribute this minus to this parentheses and get a minus x squared minus 2x plus 3. So what happens when this all happens? Well, the x squareds cancel. The minus 3 and the plus 3 cancel. The 2x and the minus 2x cancel. I can't forget this is all over h. So now we have the limit as h approaches 0, 2xh plus h squared plus 2h over h. You can factor an h out of the numerator. How is that helpful? Well, it enables us to cancel an h from the top and the bottom. And once we do that, now we have this limit as h approaches 0 of 2x plus h plus 2. And we can just evaluate the limit by substitution and get 2x plus 0 plus 2, which is 2x plus 2. Lovely. Number 13. Find the limit of f of x as x approaches 2 if this two-sided limit, if this piecewise function is defined for f. Well, to do this, we got to find the limit as x approaches 2 from the left of our function. And we got to find the limit as x approaches 2 from the right of our function. If we approach from the left, we're going to be using this function. So we're going to be substituting a 2 into 2x squared minus 4x, which is going to be 8 minus 8, which is 0. If we approach from the right, it's going to be using this function, which is 4 times sine of pi times 2 over 4. That's 4 times sine of pi over 2. Pi over 2 is 1. So that's 4 times 1, which is 4. We're supposed to find this two-sided limit. Clearly we can see that the limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right. Thusly, the limit of f of x as x approaches 2 does not exist. Just a quick reminder of why sine of pi over 2 is equal to 1. Pi over 2 is here on the positive y-axis. Here, y is 1 and so is r. Sine is y over r, it's 1 over 1, which is 1. All right, 14. We can evaluate this directly. This should be in parentheses once again. So this would be e cubed times cosine of pi times 3 over 3. 3's cancel. So we get e cubed times cosine of pi. Cosine of pi is negative 1. So this is negative e to the third. Why is cosine of pi 1? Well, pi is on the negative x-axis. Over here, x is negative 1 and r is positive 1. Cosine is x over r, that's negative 1 over 1. 15. Let's see, to evaluate this limit, we're going to have to get crazy. We can't evaluate it directly. So we're going to multiply this by 1 in the form of the conjugate of this numerator. When you multiply the two conjugates, you're going to get the first term squared minus the second term squared. We multiply the denominators together, we're just going to leave it as a product. We're not going to actually multiply it out. The top, we're going to end up with x plus, still got to use limit notation because we haven't evaluated the limit yet. The square root of x plus 3 squared is x plus 3, and a 2 squared is 4. Denominator, we're not going to change. In our numerator, a minus 4 and a plus 3 is a minus 1. Which is going to enable us to cancel this x minus 1 from the top and the bottom. So now we have the limit as x approaches 1 of 1 over the square root of the sum in x and 3 plus 2. We can now evaluate the limit, which is going to be 1 over the square root of 1 plus 3 plus 2. 1 plus 3 is 4. Square root of 4 is 2. So it's going to make this 1/4. See, we got 4 more. This next one, we cannot evaluate the limit directly because it will be dividing by 0. This doesn't factor. That tells us that this graph has a vertical asymptote at x equals 3, but we don't know if we approach 3 if the graph is going up or down. So we get this vertical asymptote. The graph could be like this or it could be like this. It's one of the two. To determine that, we're going to make a little table. We're going to put a number that's close to 3 but to the right of it into this. If I put a 3.1 in to the top, 3.1 plus 3 is positive. If I put a 3.1 into the bottom, 3.1 minus 3 is also positive. If you divide those, you get a positive number. That likely means that this is going up to positive infinity. 17. See, we can factor this one. We can't use direct substitution once again because the denominator would be 0. We can rewrite this as the limit as x approaches -3 from the right. The denominator is an x minus 3 and an x plus 3. The numerator, if you use splitting the middle term and factoring by grouping, you're going to get 2x minus 3 and an x minus 3. X minus 3's cancel. And as helpful as I thought that was going to be, it was not that helpful. We still can't use substitution for this because our denominator would be 0. This means this has a vertical asymptote at -3, but we don't know if the graph as is approaching it, is it going up or down. So I make a little table, pick a number to the left of -3, like a from the right of -3, like a -2.9. Plug that into the top, you're going to get a negative minus a negative, which is negative. Put it into the bottom, you're going to get a positive. If you divide those, you're going to get a negative. So this limit is going to be going to -infinity. As you approach the vertical asymptote from the right, it's going to be going down. That's what that means. 18. Direct substitution won't work. I feel like we already did 18. Let me just look back real quick. Maybe that was in the notes. The same as 10? It's not. It's super close to 10. I'm going to multiply this by 1 in the form of 2 and x minus 2. When I distribute that, since there's two terms on the top, I'm going to have this twice. First term, the x minus 2's cancel. Second term, the 2's cancel. So this is going to be the limit as x approaches 0. My denominator is 2 times x minus 2. My numerator is going to be 2 times 1, which is 2, plus x minus 2. 2's cancel on the top. And cancel an x from the top and the bottom. So now I have the limit as x approaches 0 of 1 over the difference of x and 2 times 2. I can now evaluate the limit by putting a 0 into the x values, and that's going to be negative 1/4. Last one, number 19. This is a piecewise function, so to find this limit, I'm going to have to approach from the left and the right and see if they agree. Limit as x approaches negative 2 from the left. It's going to be 2 minus x. This is saying x is less than negative 2. That's going to be 2 minus 2. Sorry. That's 2 minus a negative 2, which is 4. What's the limit of x squared minus 2x as we approach x equals negative, as x approaches negative 2 from the right? If we approach from the right, we're going to get negative 2 squared minus 2 times negative 2. That's 4 minus, that's 4 plus 4, which is 8. Those are not the same. The limit as x approaches negative 2 from the left, we don't have a name for this function, which is a bummer, does not equal the limit of x squared minus 2x as x approaches negative 2 from the right. Therefore, the two-sided limit does not exist. And that concludes the homework.